Welcome, everyone, to the Wharton Sirius XM podcast series on artificial intelligence, sponsored by Analytics at Wharton and Artificial Intelligence at Wharton. I'm Eric Bradlow, Professor of Marketing, Statistics, and Data Science here at the Wharton School. And I'm also, I guess for this role, I'm also the Vice Dean of Analytics at Wharton. And so I'm here interviewing thought leaders at the Wharton School on the impact of AI in business. And of course, today's episode, which is part of our multi-part series, is no exception. Today, we're going to be talking about AI and robotics, or if you'd like, AI and automation. I'm going to be talking to my colleague, Lynn Wu. Lynn is an associate professor in our Operations, Informations, and Decisions department here at the Wharton School. She teaches everyone, undergrads, MBAs, and PhD classes about the use and impact of emerging technologies. So, Lynn, welcome to our podcast.
Thank you. Thank you for having me.
It's great to be here with you. One of the things I even mentioned to you briefly off air is that a lot of people might be listening to this podcast and Sirius XM version and saying, wait a second, I thought AI was just generative AI. That's what I'm hearing about today. I'm hearing about ChatGPT and Bard and OpenAI. What the hell does AI have to do with automation? So I thought maybe for a few minutes it would be good if you take our listeners through a history of artificial intelligence and what does it mean to have artificial intelligence and automation, and then kind of how generative AI fits into the broader class of AI.
Oh, thank you. That's a great question. So AI as a field has been existing for decades, like from the 1950s and 60s. That's when people started thinking about, coined a term like artificial intelligence. And you probably, if you were around the 70s, 80s, you probably know about expert systems, which is just a bunch of rules, if-then clauses. Like if you see A and then this B happens, and they think that will code out lots of, medical knowledge or other type of knowledge out there. And that didn't work so well. And then come the neural networks. And the neural network was happened around the 70s and 80s again. And at the time, it wasn't performing very well because, as you know, neural networks needs a lot of data. And comes the 90s, actually, we had AI winter. Basically, neural network wasn't working. A lot of AI techniques weren't working. So they actually thought AI is not going to happen for a long time. And then we had the internet explosion. We have all the digital traces of our, internet activities, our search activities, our social media, our videos, our photos. And that data explosion ultimately fueled the current AI revolution. Because now the neural network has a ton of data. And then you can build up very, very big neural networks, which we call deep learning. Okay? And deep learning was driving the AI revolution from 2010s to about 2018. And then a special type of AI techniques called transformers, which is basically, you think about, just make AI neural networks run really fast, computationally very efficient. And again, saves a ton of resources, and that allows generative AI. So that's although I'm really simplifying things, that's just what it is. So if you think of generative AI, it's only a tip of the very end. And although it's transformative, I absolutely agree with you. If you see ChatGPT and DALL-E is amazing, but it is really just an extension of existing technology in neural networks and deep learning.
Yeah, it's just in this case predicting it to language. So these are large language models, but there's, as we're going to talk about today, there are applications of AI in many, many different areas. And also, I think it's also valuable for our listeners to know, a lot of us trained back in the old days as statisticians, but even all of us are familiar with regression, which is obviously a form of linear prediction models, and neural nets, obviously, and deep learning just allow for much more complicated interactions between variables. And that's what I think, maybe you could just comment briefly on this. That's why these simple rules tend not to work well, because the way real life works isn't just simple if-thens. It's not like a linear regression, more is necessarily better or worse. There are these complicated relationships.
That's exactly right. So often we cannot describe a relationship using a simple representation or a linear model. What neural network does is you can have link variety of different functional form in a way that we cannot describe at all. But machine knows how to transform input outputs through many different layers of transformations.
Well, let's actually talk about the main topic. And first of all, thanks, Lynn, for bringing that up because, again, a big part of this series, a lot of people are talking about generative AI, and you've just pointed out it is just a special case and a specific application area. So let's talk about this. As a matter of fact, one of the things I present to my MBA students, which is interesting, that it's something that you wrote down in advance as a question, is that previous studies have indicated that between 40 to 70% of jobs could be automated. So let's start with, which jobs do you think could be automated? And two, what would prevent that from happening, or there is kind of no way back at this point?
We're talking about generative AI specifically, like the ChatGPT, like this currently.
It could be, or it could be, for example, now automation and artificial intelligence is going to allow robots to do lots of physical tasks that we couldn't do before. So it could be vision-based types of jobs and opportunities. It could be, I don't know, robots doing surgery. It could be robots replacing people in plants. It could be in lots of different ways.
Okay, great. So let me be more concrete. Let's talk about robotics. Okay, so how physical robots can change labor composition, right? So contrary to the popular notion that 40-60% of employees are actually getting laid off when they have no jobs, so in our longitudinal research over about 20 years using Canadian data where we capture every single robot being used in the firm, in the establishment, and look at what kind of employees are working with the robots, who are there and who are not there anymore, and the revenues, their firm practices in terms of HR management, in terms of how people are being rewarded. So we found interestingly that when firms adopt robots, they actually hired more people. They did not lay off more people.
Very interesting. Why? So why is that?
It actually turns out it's the robot adopters who are becoming much more productive and much more efficient. So they grow their pie bigger and hire more people. So it turns out it's not the robot displacing people directly. It's the robot non-adopters are no longer competitive, and they are laying off people.
Okay, so this is actually, as a statistician, this is an interesting, what I'll call self-selection problem. So the fact that someone has adopted robotics is indicative of the likely growth pattern of the firms, and faster growing firms tend to hire more people. Is that is from a selection bias story, is that the selection argument that's being made?
That's a very good point. So we actually looked at the type of people that are being laid off.
That was going to be my next question.
Right. So I think I can talk about statistics, the methods we did, but I think it's really probably easier, intuitive to understand.
But let me just understand, if I hire a robot, if I build a robot or utilize a robot to do a specific type of task, are you suggesting that the firm hires more people to do that type of task, or the firm hires more people in general to do other tasks? Because now this task is done more efficiently, this firm can produce more units, and now I need more people in other jobs.
It's latter. It's really latter.
The latter, okay.
Right, but no one is doing everything. Like robots are not doing everything a human can do yet. So the robots are replacing part of a task a human worker used to do, but increase the demand of the other tasks that person used to do. So if you are a manager and you're mostly looking at quality assurance issues, if that robot's taking care of that, you can do more leadership. You can do more people management. Like you do the other work that robots, can't do yet.
I see. Now, your paper finds that the case for employment, this to me, I love it when people find things that are counterintuitive. Your paper finds, what I've written down here, that the case for employment is reversed for managers. That is, more robots can equal fewer bosses. So tell us about that, because that must have been one of the, to me, intriguing findings, because I think most people would say, no, it's the, I'll call it lower level laborer that's going to lose their job, but managers, someone has to make decisions. You're fine.
Yeah, that's also a very intriguing finding. We thought we got it wrong at first, so we really double-checked, quadruple-checked, and then we find out why. It's a two effects. One direct effect, right? I mentioned the monitoring technology can't figure out what your employees are doing, right? Because you think about a laptop. Well, you can't even figure out every key the employee can type if you want to, right? And in a warehouse situation, you're clocked in each box coming in. They know exactly what you've done. So you don't need a foreman or a person who will see you actually doing the work, because there's all automatic captured, and then your performance reports are automatic generated. So that part of the managerial task is being directly substituted. So you see in the very beginning, within 0 and 1 year of adoption, you see a slight dip in managerial work. But then after 2-3 years, you see a really big downturn, a very sharp downturn. So why is that, right? That's no longer a direct substitution story anymore.
Okay.
What happened is that the composition of labor, the employees at the firm changed, right? So if you think about what robots can do, it turns out robots are really good at doing the middle skilled work part. So they're not very good at, doing thought leadership, thinking about what to do. That's what humans are doing. We need to figure out our goals. We need to, figure out what to do and execute it and write a plan to execute it. And then, but robots are still not very good at some of what our hands can do. Like tactile sensors, like the residual task. Somebody still need to, pick up a ball and put it in a box. In various shapes and forms. Our hands can handle infinite shapes. Where a robot, you got to train a lot of time to handle one type of shape. So that versatility, although people are still working on making a lot of advances on this area, but the versatility of robots is not there yet. You can train a very narrow task, but you cannot generalize very quickly to lots of tasks.
And do you think if you've the explosion of transformer models, so the ability to handle richer and bigger and larger data sets in real time is even going to threaten that in some sense robots are going to be better at very, let's call them fine motor tasks and complex tasks, and it's just a matter of time even before, let's call it, the pie expands to even more fine motor types of jobs?
People are definitely working on that, but I do want to caution you that for robotics area, it's the data generation, it's just not there as of AI. Because AI, you can simulate lots of different kind of data, right? Like your pictures, your videos automatically there on the internet, you can just grab it, right? But if you want to train robot, you gotta train them in realistic settings when humans are involved.
So why can't you have, as a form of, by the way, the term, you might call it a form of supervised learning, why can't you have a bunch of humans doing a task? I actually have video cameras with extraordinary, maybe the person has sensors all over their body, and now all of a sudden I've got this extraordinarily rich data set of movements and actions and stuff, and I'm going to use AI to train the model to start using robotics to replace those tasks. Is that because companies are not doing these types of, I'll call it, measurement experiments in large scale, or why can't that be done?
I think you can do that, but again, it's only for a very narrow set of tasks. Unless that task has extremely high value to the firm, that makes sense, right? And also, most of the robots, you can't just plug in a robot in a firm and then expect it to be autonomously working on its own. So there's always a human monitoring or working with robots in many. That's cobots. Like a lot of the new development using more advanced techniques are cobots. And these cobots is usually human-machine interaction. In those scenarios, right, you actually have to generate human-robot interactive data. And that's something you cannot just simulate. You actually have to capture, right? You can put a sensor all over me or robots, but you got to catch me everywhere. And that's just hard to capture, right? You can't just put in a car in the road, right? Capture all this stuff. But when the humans involved, it's expensive, right? Capturing that data is really expensive. So in terms of that data, I would say robotics at least 10 years behind in AI in generating the techniques that can do what generative AI can do.
I see. We're here on the Wharton Sirius XM podcast series on artificial intelligence, sponsored by Analytics at Wharton and AI at Wharton. I'm here talking to Associate Professor of Operations, Information, and Decisions, Lynn Wu. We're talking about AI and robotics. So let me ask you, how should firms think about their employees now, or how should employees think about the skill sets they need to develop to kind of continue to thrive in a world where I think we agree it's unlikely robots are going to be doing less overtime, probably more overtime. What can employees do, and how should firms think about managing them?
I think one of the biggest things humans tend to underestimate is that we have a lot of tacit knowledge about how work is being done, right? So robots can only observe, a small part. A lot of our knowledge is not codified. for machine to consume. So the more knowledge you have that's not codified, the better off you are, because there's no way robots can use that knowledge to replace you. But then again, that's very abstract, right? But if you have been in a firm in the industry for a long time, you have a deep expertise knowledge about the industry or about that firm, is always going to be good, because that knowledge cannot be easily transferable outside.
Has anyone, I don't know, I'm sure someone has studied this. Are employees strategic? Like, for example, maybe it's the classic, I teach my student, but I don't teach them everything I know. I teach my student, strategically enough. But if I give away everything, then in theory, maybe I could be replaced by a robot. Is there any studies that have been done on the strategic nature of employees?
I am sure it has been done. I think more will have to be done, because as a lot of firms these days are using human to train robots. I am sure those kind of strategic behavior will become more and more prevalent. There are some literature back in the 60s, 70s, but I think that needs to be updated.
I see. So do firms have a choice? Like, is there any choice firms really have? Or in some sense, I do a lot of work in sports. Do I really need some former 50, 60-year-old baseball player throwing batting practice? Why don't I just get a robot to do that? I study things in high tech. Do I really need some sort of human supervision anymore, where I can just have a robot do it? Are there any specific, can firms really compete in scale nowadays without adopting robotics? Or another way to frame it is there any industry you think that is essentially immune to it?
Based on my study in Canadian data, I think it's not immune. Because adopters are really just killing the competition. Unless nobody in your industry collectively decide not to adopt robot, I think you're going to worry about new entrant coming in with a robot. So I think you have to be forward-looking, at least, and think about how robots is going to affect your firm and productivity. But the most important thing is not like, oh my God, my competitor adopted robots, I need to do it immediately. And I would caution that, because the value of adopting robots is really to help you understand your existing firm processes and how to help you understand which part can be automated and which part can be strengthened to complement that automation. But in fact, I would say 9 out of 10, 90% of value come from studying that process, understanding where it can be automated, where it cannot be automated, and how to strengthen that relationship between human and machine, that collaboration. So this is not a adopt robot, buy some expensive hardware, and get some consultant, and you're done, right? This is require people in your firm been doing that process for a long time, and from them they can tell, this part of the process makes sense. Actually, yeah, sure, the robots can do it, but I don't think it's a good idea, because this is a very risky operation. If something happened to if something happened to the person, it's very dangerous or high risk situation, then it should not be automated, even if it can be done. So it's really understanding that process and deciding human decision here, understanding where it can be automated, where it shouldn't, even if it can. That is where the value comes from.
So let me ask a question about, it's really a two-part question, but it's really the same question, which is, so how big an effect are we talking about here? So a firm hires a robot, and then some measure, and this is the second part, but it's really the same question. First of all, what are in our language as academics, what are the dependent variables that people worry about? So let's imagine you have a model that says, if I adopt robots to a certain degree to do a certain task, let's say I care about sales, or market share, or employee retention, or employee satisfaction. What outcome variables do people tend to study when they think about the adoption of robots? That's number one. And second, how big an effect size are we talking about here? Of all the ways that a firm could improve efficiency and profitability, is this in the top 5? And how big an effect are we talking about?
That's a great question. So obviously, as economists, statistician, we capture any variable we have in our arsenal, right? Revenue, employee satisfaction, individual productivity, performance, right? And that's the great thing about the Canadian data set, is that we actually have a lot of that data. We look at employee satisfaction, their incentive pay system, so we were able to capture a lot of this. It is a very important study in terms of what firms should, what the effective size is.
And what did you find? How big an effect are we talking about? What happens? I'm just saying, let's say, the way we always tend to think about it is there's always 3 populations, at least the way I think about it is, what happens to firm? Let's even just say we're thinking about profits or surplus. What happens to the firm? What happens to customers? And what happens to society?
Yeah, let me just go by the revenue, like profit first, right? So if you think about a profit maximizing firm, right? You should like, so I got one robot, I got $10, and if my robot is only costing $1, right? That means I should just buy more robots until I reached exactly 10 robots, and then I got the same value in, same value out, right? I put in $10 robots, I got $10 of output out, right?
Right.
That should be the profit maximizing firm, right? So in fact, what we found is that robot is 10 times that factor share. So that's 10 times the value. So you put in 1, you get 10 back. That's what we found.
But there has to be some sort of diminishing marginal returns to robots. Like the second robot's got to be worth maybe a little bit less.
Yep.
Of course, my cost might go down as well.
Yeah, exactly. So there's that. But what I want to emphasize is not that robots responsible for the whole 10 here. 9 of them come from process improvement.
I got it.
The stuff you do to make robot work. So the robot's 1 because that makes sense. You possibly maximize it to 1. But the 9 is what you do with it.
I see. And what about for employees? Like, so you could imagine one of two things. One is the employees that are still remaining. Now that the firm's making more money, you could argue that the employees are in better shape than before. I don't know. What do you find in terms of employees?
That's great. What we found is that it's precisely when humans are working with robots, like robots make different kind of errors than humans. Right? So if you and I work together, we could collude in a sense. Let's share today, right? It'll be like our machine died. So let's just have a coffee, right? I'm not saying it's going to happen, but we could, right? And a manager sitting far away where cannot see you, or a headquarter couldn't figure out, okay, they cannot directly observe you. Say, oh, okay, I guess the machine wasn't working. Let it repair it, right? But when you are working with a robot, you can't do that anymore, right? Because robots are doing these things. These kind of errors is less likely to occur. Because human or robot have different errors. That means when you're working with a robot, I can tell your performance. I can capture your performance more accurately than you work with the human. So what happened is that firm adopting robots also change their performance pay practices.
I see.
So they actually become like they are rewarding the high performers more so than before. Like you are actually good performers, not because you are lucky or some other stuff.
So good performers in some ways should be happier with robots because in some sense there's less measurement error in their performance.
Yep, that's exactly what we found. There's less team-based promotions, incentive pay, but mostly more individual-based performance pay. To what extent it's going to happen in the future, I don't know, because we see a lot of problems in the individual performance pay too. But at least right now, the swing, the pendulum is more toward individually based incentive pay.
And how about, policymakers? So how should this be a regulated market, or is this just, I think most people on the surface would say this is bad for society because it's replacing paying jobs for humans. Although on the other hand, there could be greater efficiencies. How should policymakers and society think about it?
I think the genie's out of the bottle. You can't put it back anymore. You can't just say, let's not use AI because the U.S. doesn't use AI, the other country would. And so as we have to be competitive in the national front as well. In terms of regulation, I think it's really important we actually study the phenomenon to greater detail. We see generative AI, people getting worried, but we really have to see evidence. Does it actually make consumer worse off? Right? Does it actually hurt people? Because remember in my robot study is premised by saying robots will kill 40 to 50% employment, but we found opposite. We actually found employment to have gone up and quite a bit. So we really have to have large empirical evidence first before we make any significant policy changes, because we don't want to, throttle this process. We want AI to grow before we kill it completely, just without having evidence that it's going to actually have significant harm. I'm not saying it won't have harm. It will, but we need to watch and monitor closely before we make any decisions.
So maybe in the last minute or so that we have, could you tell me if we were sitting here 10 years from now, and maybe we will be, so as we look back on those 10 years, what are we saying this has been the big advance in AI and robotics?
Oh, I think generative AI is for sure the most prominent advance in NLP. It pretty much wiped out all the existing natural language processing techniques out there. This is de facto replaced it. So I think this entire field needs to be revolutionized. So in terms of, I think the next 10 years, we're going to see it may not be necessarily a technology advancement in that area per se. Is really about the application. How is that applied to marketing? How is it applied to schools and education? How is it applied to writing? How does it apply to reporting? Like as industries are starting to find novel use of this technology, then that's where we're going to see how amazing it is. Just like think of internet. Internet was invented in the 1970s, but we didn't really see amazing how the potential of it in 2000 with the .com, right? With the internet, with e-commerce. So I think generative AI may be faster, but it will still be a decade or two until we see the real impact.
Well, I'd like to thank my colleague, Associate Professor of Operations Information Decisions, Lynn Wu, for joining me today on the Wharton Sirius XM podcast series on artificial intelligence. Today we've been talking about AI and automation. We have plenty of episodes to go, but Lynn, thank you for joining me today.
Thank you for having me. This is so much fun.